Um, Hello again, and welcome to the part 3 of the lecture. We will the physical aspect of the eye. How can we see the images? Simple is when the image, just when the object is here, the light will be coming from the object and will be reflected by using the convex, which is the lens that we have, the convex lens, and then the image should be precisely on the retina. Okay, so when the image will be precisely on the retina, this is the point here that we will see everything. That means you can see clearly. So the image must be fall precisely on the retina to produce a clear image. Okay, but we have and a person can with the ideal vision, can see object clearly at distances ranging from 25 centimeter to essentially infinity. So you can see from 25 centimeter far away from the lens till the infinity. So this is the idea. Now, if you remember, it just like we have 1 over f equal 1 over u plus 1 over v. Okay, and this is, we name it as the lens formula. All right, so basically is depending on the math or physics. If you have u is constant, if this one is constant, when f is changed, the v will be what? Will be changed as well. Okay, or let's say I will write another form. Let me clean this one. Okay, and I will write another form. It just said 1 over p equal 1 over u plus 1 over v. Okay, which is the same, p is the same of 1 over f. So when in physics or math, when the u is constant, when this one is constant, when the p change, v should be changed as well. Or when the v change, p should be changed as well. The same idea is just when the 1 over u plus 1 over v. When the v is constant, so when the u is changed, what will happen to the p? Well, p is changed as well. Okay, so now let's see your eyes here. Let me do it on the other side. Okay, see your eyes here. I'm using this two. So the distance here between your eye and the lens and the retina, the image, between the image and the middle of the lens, we name it what? We name it V. Yes, the image distances. All right. Here again, the same. The image between here and here, it will be the distance here, it will be V. All right. So as the V can be changed, V is cannot be changed. V always is constant, is equal to 2 centimeters. Okay, so when the V is constant, what does that mean? That means when the U will change, the power will be changed as well. Okay, so that's mean when the object will be far away from you, this one will be high number. That means the pressure, the P will be what? The power will be low. So that's mean your eye will be relaxed or less power. Why? Because the object is far away from you. And when the object is close to you, this one will be small in terms of numbers. The P will be what? P will be high. So your lens will be more powerful because of the, to make the, all of these things happen because to make the image where precisely on the retina. So basically is just like since the light ray from the nearby object can be diverged and still enter the eye, the lens must be more powerful. When the object is close, the lens will be more powerful for the close vision than the distance vision. The lens is made thicker by action of the ciliary muscle surrounding it. The eye must be relaxed when the viewing object, distance object. When the object is far away, the eye will be what? Will be relaxed. This is the, we name it the adjust of the eye. The vision of very distant object is called total relaxed, while a close distance is termed accommodated, with the close vision being fully accommodated. So when your eye is accommodated, that's mean the object, the eye will be more powerful, and the image will be, when the object will be close to the, that means the object is close to the eye. When the image, it will be relaxed, that means the eye will be, the object will be far away from you, and the lens will be more relaxed to get the image precisely on the retina. This is the fact. This is happen when you have ideal guys, ideal eyes or ideal vision. The problem is when you don't have ideal vision. Okay, so that's mean when your eye, when your lens is still strong, is too strong, and the object is far away. So when the object is far away and the image and the lens is too strong, that's mean the image will be not precisely on the retina. The second case, when the eye is too long. So when the object is far away and the image will be here, that's mean you will what? You will not see the object clearly. And as we said, the point is you should see precisely. How can we see precisely? By making the image precisely on the retina. The same idea when you have the lens will be too weak and the object is near to your object, or the eye is too short and the object is close to your eye. And these diseases, we name it as farsightedness or nearsightedness. Farsightedness, that's mean you can see the object clearly when it's far away from you, and you cannot see the object near to you. And nearsightedness, that means you can see the object close to you, you cannot see the object far away from you. So from the near, you can understand that means you can see the near object, and far, you can see the far away object, and vice versa. So nearsightedness, that means you can't see the far object. And farsightedness, that means you can't see the near object. Now, how can we correct the vision for that one? As we said, the normal vision, that means this is the object. The eye will be make reflected, and then we'll make the image like this on the precisely on the retina. So this is the normal vision. What will happen when you have a nearsightedness? That your eyes is too weak. So that means the object you will not be precisely on the retina. That means you cannot see it. So what you will do? You will make a lens. This lens will make the object will be precisely on the retina. So this lens will be help your eye to make the image precisely on the retina. Okay, and this one we will explain in details in terms of the theory, in terms of the lecture, inshallah. For the farsightedness is the same idea. This is the object. If the object is close to you, in the farsighted you cannot see it. So you will put the image. This lens will be create the image that you can see it clearly. So always the image that you are seeing in terms of the farsightedness or nearsightedness is not real image. This is not the real image. Okay, why not real image or not the it will be the not real one? Because the image will be created is the virtual image. Okay, it's not the original image. All right, and this is how it's to work. The third device is named astigmatism. Astigmatism is a common eye condition that affects the way that the light enters the light, leading to the blurry and distorted image. So the image here, you will see the light will be just reflected and distorted, okay? So you will not see clearly. You will see, but not clearly with the blur vision. Unlike the healthy eye with the round cornea, the clear front surface of the eye in the astigmatism, the cornea is shaped more like football or egg with varying degree of curvature. So it will be the lens will be not like a basketball like this one. It will be like the ball. So this is why you will see not clearly. Okay, how can we read the image using the prescription of the eyeglass? First of all, in terms of the image, you will see OD and OS. And OD mean oculus dexter, which is the right eye, and OS mean the left eye. Okay, the plus, you will see it. Any plus, you will see it. That means is a farsightedness. If you see minus, that means it's a nearsightedness. For example, here is a nearsightedness or farsightedness. All right. For example, if your prescription said you have one, that means you have one diameter of nearsightedness because it's positive. So nearsightedness, sorry, -1. This is -1. So because it's minus, that means you have a nearsightedness. For example, if you said you have -4.5, that means you have a 4 and a quarter diameters of nearsightedness. Why? Because it's minus, and this is the power of the eye. This is more nearsightedness than -1 and requires stronger or thicker lenses. How can I read this one? First of all, we have a sphere, we have cylinder, we have axis. We will not focus on these three. We will ignore them. We will focus on these only three: the sphere, the cylinder, and the axis. The sphere, it gives you if you have a farsightedness or nearsightedness. For example, if it's -4, that means you have a 4 diameters of what? Of nearsightedness. Okay, in which eye? On the right eye. So the sphere is just the spherical portion of the prescription, which is the degree of the nearsightedness and farsightedness. What about the C or cylinder? The C, sometimes cylinder, sometimes C, is referred to the cylinder or the astigmatism. Okay, if you have astigmatism, it will be put it where? On the cylinder one. For example, here on his left eye, he has a astigmatism, is 0.5. Okay, with a degree, and this is the astigmatism. And just like the axis is the number anywhere from 0 to 20, 180 degree, which is the orientation of the astigmatism. So if you have astigmatism, you will have axis. It's the orientation of your eye. Okay, if you don't have astigmatism, you will not have axis. This is how it's work. Okay, and this is the end of section of part 3. Thank you very much.